Hi, everybody, and welcome to Programming Fundamentals. It's week 8, talk B on the Higher Diploma in Computer Science. Last week, or sorry, in the last class, we were looking at Shop version 2, and we'd implemented Shop version 2 using arrays. So we had to have an array, and we had to have a field called total to keep track of how many products were in our store. We then paused and we introduced something called collections in Java. These are found in the Java utils package. And we looked at a specific collection called the array list. And inside our array list, then we looked at the various methods that we can access, how to initialize and declare um, object variables of type array list. And then we looked, or we are going to look, at how we can use that array list inside our shop. Um, the example that we looked at the last class was using the array list in a notes application. And now that we see how to use an array list, we're going to recap that at the start of today's class, and then we're going to use it in updating our shop to introduce shop version 3. Once we've gone through all of that, at the end of the class, we'll make some time then for maybe working our way and taking a look through some feedback on your first assignment. Okay. So in relation to array lists, we saw how to group objects, developing a basic personal notebook project using collections, and the collection was the array list. We also looked at indexing with collections, retrieving and removal of objects. We saw the 5 main methods, which we'll recap again in a minute. And then we looked at iterating through an array list. So we used the for loop, used the while loop. Then we introduced a brand new one called the for each loop for visiting every element in an array list. So let's look at how we declare and initialize an array list. First of all, we need to import the array list class from the Java util package in the first import statement here in our code. Next, inside our notebook class, we saw how to declare notes. Here, notes is a private object variable of type array list of strings. So array list is a keyword, and it's a parameterized object. So the parameter is angle brackets, and inside the angle brackets, we put an object type. So this declares notes as a private array list of strings. Next, notes is initialized by calling the constructor using new keyword, which we've seen before. But it's important that we put these parentheses at the end. So we'll see new array list of string and then parentheses. So this is what initializes notes by calling the constructor method using the new keyword and the parentheses. There are 5 key methods built into array lists. We have add, clear, get, size, and remove. Add for adding to the list. Clear just clears out all the elements in the array list. Get is a method for pulling back a specific element within the array list. Size will tell us how many elements are in the list at any given time. And remove for removing a specific element. Remember, when we remove an element, the indexes all get changed. Here's the for each loop iterating over a collection, for example, an array list. We can see that the way we read this is new. We have new syntax here. For each note of type string in the notes collection, we print out the note. So it's important that you get used to this notation and you're used to reading it out as I have just done for each note. And we see that I'm saying for each note, which is of type string, notice the colon, in the notes array list, notes collection. And we know that notes is an array list. And then system.out.println. And then what are you printing out? We're printing out the specific note from that notes collection. So this syntax is important And it's one thing being able to write it, you also need to understand it and to be able to read it out. So for an array list collection, we specify the type of collection. For example, an array list of notes. The type must be an object, can't store primitive types. And the type of objects it will contain, for example, a string. And that goes inside angle brackets. We say notes is an array list of string. So let's look at a summary then. The Java Collections Framework is what we're looking at, specifically the ArrayList class. This is part of the Java util package. If we want to use it, we need to import java.util.arraylist. So this will be one of the first lines you will have at the top of your code. We have notes here being declared as an array list of strings. Private keyword just says that it's private to this class and only methods within this class can change it. Next, we have notes is a new array list of strings with parentheses at the end. This is how we initialize notes. This effectively allocates the memory for our notes array list by calling the constructor method. It's the bracket at the end that does that. Then we have notes.addNote. So here we're calling the add method of the array list. Our array list is called notes. It takes a parameter, and the parameter is a specific note that you want to add. Size at any given time will tell us how many elements are in the array list. Takes no parameters. Get takes the index as a parameter. It's a get method. It will return a specific element of the array list collection. Remove will delete a specific element from the collection. And then we saw our new syntax for iterating collections, the for each loop. Again, for each note of type string in the notes collection, what do we want to do? We want to print line that specific note. So notice that there's no index being used. There's no loop control variable being used with the for each loop. So that's a recap on array lists, and we're going to be using array lists now in our shop version 3 application. We're going to replace the array and the field total with just an array list, and then we're going to have to update some of the methods to make use of the methods that we just outlined for array list in order to make our shop version 3 work. Again, visually, this is what we have in shop version 2. We have products, which is an array of product. And we keep track of how many products using the total field. In version 3, we're going to change that to just use an array list of product. So products is still the name of the array, but we're using an array list now. And because we're using an array list, we won't need to use the field total. So let's take a look at shop version 2. We have 3 classes: driver, store, and product. There was some changes made to driver. Store was a new class that was introduced, and we didn't make any changes to the product class. Product stores 4 fields. Details of a product's name, code, unit cost, and whether it's in the current product line or not. Store class maintains a collection of products, i.e. an array of products in version 2. And driver allows the user to decide how many product details they want to store, and then the methods are updated to work with this new stored products array. So that was version 2. We're now moving to shop version 3. The goal is to use an array list of products instead of an array. So we're going to be updating our 3 classes. We're refactoring driver. Any changes to the store interface are reflected in this class. We'll also refactor store to an array list of product from storing products in an array. And there's no changes to the product class for version 3. Okay, so there are no changes to the product class, but it'll do us no harm to maybe take a look at that first. This will help us recap classes and object-oriented approach. So our product class, this is what it looks like within IntelliJ. We have fields indicated with the F. There are 4 fields. We have the product name, the product code, the unit cost, and whether it's in the current product line or not. In IntelliJ, the names comes first and the types come second after the colon. We also have the constructor method. Remember, a constructor method has the same name as the class. In this case, it takes in 4 parameters: string, int, double, and boolean. And those 4 parameters then initialize the 4 fields that we just outlined. To ensure that we have encapsulation, those fields were private, hence the padlocks being closed. And then we need some way of accessing them. We need the accessor and mutator methods. So the accessor methods are the getters. So we have a method to be able to return the value of each one of the fields. So we get product name, get unit cost, get product code, whether it's in the current product line or not. And then we have a corresponding group of setters. So 4 methods for changing the values, and each one of these then will change the values in the fields. So we set product code, set product name, set unit cost, and then set in current product line. There's one other method mentioned here, and that's the toString method. And this is a special method that's used for returning a string when you want to print out an object. So when we print out an object, the toString method is called to specify what will be printed out. And this just allows us to effectively create a nice pretty way of printing out the contents of the object, so you can basically build out the string as you decide. The product class contains 4 fields. Here they are. So what we're doing now is looking at the code implementation rather than just the IntelliJ interface that we looked at on the previous slide. So we just have a field name for each of our fields, variable name. Each one of these is private, and then comes the data type followed by the actual name. And these are all declared just inside our class product. The constructor uses the data passed in the 4 parameters to update the instance field. So here's our constructor. It's product, same name as the class. It has brackets, and inside the brackets we will see that we've got 4 parameters. We have product name, product code, unit cost, and whether it's in the current product line or not. And each one of those has a different type. So we have string, int, double, and boolean. That correspond with the types of the fields in the class. So each one of these parameters appears on the right-hand side of an assignment statement. The left-hand side uses the this keyword, which is for name overloading. So we have this.product name is assigned a value product name. The this.product name refers to the field, and the product name on its own is referring to the parameter, and likewise for each of the other parameters and fields. The class also has getters for each instance field. So remember, we have 4 fields, which is shown there on the bottom of the screen, and we need to create a getter method for each one of these. Remember, getter methods, all they do is return what the value of the field is. So the contents of the method is just return and then the field name in each of those. We also need setters to be able to change the value. So we have set product code, set product name, set unit cost, and set in current product line or not. Each one of these methods takes in a parameter, which corresponds to the field name. And we have this dot field name is assigned a value, the parameter, in each one of these. And then that final method was the toString method. We said the class has a toString method to return a string containing a user-friendly representation of the object state. So if we look at the contents of the toString method, it's a return and it's returning a string. But we get to decide what way the string is formatted. So we've got product description in double quotes. Notice the colon and the space, and then we're adding the value of the product name field to that. Then we're adding a comma, space, product code, colon, space, and then the field value of product code, likewise for unit cost and whether it's in the current product line or not. So the output then looks like this. For a specific product, we might see output like this. So product description is product 1, comma, product code 1, comma, unit cost 45.99, comma, currently in the product line is true. So this is the string that would be returned from our method toString. Remember, it's a method that returns a string, and this is the string that might be returned for a specific product. We'll call this method from the store class that we're going to construct over the next few slides. Okay, so we've seen the product class. Next is the store class. Let's take a look. The idea with store is we're going to refactor to an array list of product from the products array. So here's what it looks like in IntelliJ. We have a field, products, as before, but now we're using an array list of product. The constructor method is going to have to change. And then we've got a list of methods for working on the store. We haven't implemented any of these yet. Or sorry, I should say we haven't implemented them all yet. We've implemented some. So we're going to focus in today's talk on the first 3 of these. Now the store class now has just one field called products. This is an array list of product. And my question is, why don't we have the field total anymore? So I'd like you to think about that, pause the video, and when you think you've got an answer, resume. Okay, let's take a look at why. When we were working on our shop version 2, we had 2 fields in the store class. First one was products, which was an array of product. And the second was total, which was an integer to keep track of how many products were currently in the store. Now, because we're implementing an array list in version 3, we actually only need one field. And that field is the array list of product, because one of the methods that's built into array lists is that we can find out how many items are in the list at any given time. Remember, an array list is dynamic. It changes its size over time. So that's really useful because it's keeping track of how many products are in the store. We don't have to, okay? We can pull back that value by looking at the size method. And that will tell us the equivalent of what we were previously storing in the total field. So that's why we don't have total anymore. We can get back the total by just calling the size method of our array list. So let's look at then how we use our array list in this application. In the previous application, we had an array list of strings. In this application, we're going to have an array list of product. So before we can use an array list, we need to import the array list class from the Java util package, which we do here. Then inside the class, we're going to declare our array list. Here we have products, which is an array list of product. It's a private instance variable, which means only methods within this class have access to it. And then here we're calling the constructor of the ArrayList class to build the ArrayList object. Remember, what's important here is we have the new keyword, the ArrayList of product, and then the bracket after. So this is what is going to invoke the constructor method to initialize our products object variable, which we declared up here. So this is an important slide for using array lists, how to import the ArrayList class, how to declare the ArrayList variable, and then how to initialize that variable. So we're going to look at three methods in today's class. We're going to look at the first three: adding a product, listing products, and the cheapest product. Now the other methods we'll implement next week. So the first one is to add a product to the store. Me calling out the word product over and over and over is not going to help. So what I've done is I've used color coding to help you identify what we're talking about. So we're adding a product object to an array list of product. Adding a product object, that's in blue, to an array list of product, which our array list I'm representing in green. The red here is the type, and that type is a product class. So we have the array list holds objects of this type, which is the product class in red. Next, we have the object variable product, which is of type product with a capital P in red, that we want to add to the array list. So to add to an array list, we're going to be using the array list of product, which is called products, S, and that's implemented in green. And we're calling the add method of that array list. The add method requires us to pass in a parameter, and the parameter that we're going to pass in is the product. So just to be clear, we are implementing the add method for our store class. It takes in an object variable, product, of type product, and we're using that product to pass into the add method of the array list products. So what we looked at on the previous screen is inserted inside the store class. The pink box here is exactly what we had on the previous screen, and I'm just showing you where that fits inside our code. So the second method we're going to look at is listing products. Now we've got some code. Let's just give you a second to review that code. Okay, so let's walk through it. We have public string list products. So list products is the name of the method that we're implementing in the store class. It starts out with an if statement. If products.size, where products is an array list, so we're pulling back the number of elements that are in that array list, and we're saying if it's 0, just return we have no products. Remember, list products is returning a string. So the string we're going to return is no products in double quotes. So that's what happens if there's no elements in the list. If our array list is 0. Otherwise, we have the else statement, the else part of our if statement. If there are products in the array list, return a string containing the index number of each product and the product details associated with the product at that index in the array list. So we have for int I is assigned a value 0. Keep going while I is less than products.size, incrementing I by 1 every time. So we're going to visit every element in our products array list. And we're building up a string each time. So we're saying list of products, which is a string, plus equals means it gets the value that it currently has plus whatever comes on the right hand side of this operator. And that is I, which is the loop counter variable, plus a colon and a space, plus products.getI. So that's going to bring back the fields of the current product as a string and add it to this list product string. And it does that for each one of the products. We then finish by returning the list of products. So what output might we see? Well, sample output might look like this. Let's say we have 3 products in our store and they're indexed 0, 1, and 2. So the size would be 3. So we'd be saying for int I is assigned a value 0, keep going while I is less than products.size, which would be 3. Keep going while it's less than 3, so that will visit 0, 1, and 2. And what are we doing? Every time around the loop, we're printing out I, hence the 0, 1, and 2. And then what comes after that is what is stored for that product. So this is the toString method of the product class that we looked at in the previous section. So effectively what we've got is an index and then the product details. The product details will be the product description, product code, the unit cost, and whether it's in the current product line or not. And that's all labeled out and pre-printed. Okay. So the important bits here are products.size tells us how many elements, how many products are in our array list. And products.get brackets I is getting back the product at the current index. So it's accessing the current index in the array list. Okay, so you might be tempted to use a for each loop instead. So let's take a look at that. So we could have, instead of iterating, we could have used something like this. Because we need to print out the index, we could have used the for each loop, right? So we have for for each product of type product in the products array list, we are visiting each element, and we've got list of products. There's a string being built up. We're adding the index to it, just as before, colon and space, and then a product, which is the current product that we're looking at in the loop. Now that's nice, but it's not really of much benefit because we still have to now maintain this loop counter. We have to maintain the I, so we'd have to initialize it outside the for loop. We'd have to increment it inside the loop, and then we have to use it in our string. So the idea of the for each loop is to not need the counter index. If the requirement here is that we need to output the index, then there's no real benefit of using a for each loop, because we're still getting the same output, but we've had to create a quite messy approach to getting that index. Where it would have been of benefit is if we look at the next screen, which has the for each loop version 2. And here what I'm saying is, if we didn't need the index in the output, then the for each loop would have been a better approach, because what we have is for each product of type product in the products array list, our output would be list of products plus equals the product, current product, and that's it. But the problem here is that we lose our index. We have no index. Okay, so I just provided those last two slides just because we've been looking at for each loops. I want to just show you where you would use them and where you wouldn't. Okay. Okay, so let's take a look at one more method in the store class, and this one is to find the cheapest product. And to do that, we're going to be looking at an algorithm to find the smallest item in a list of numbers. So let's take a look at it. So we're looking at finding the cheapest product and returning a string, which is what is the name of the cheapest product. So to do that, we have a simpler problem that we need to look at first, and this will help with the coming slides. So here we have a list of 7 numbers. You take a look at those numbers, which one is the smallest? So I'm sure you got the right answer being 2, of course. But now what I want you to do is think about how you got there. So how did you find that 2 is the smallest? So one approach that people would do is they would start at the first number and look straight across the list. And in their mind, they're looking for a number that's the smallest. And with a small list of numbers like this, that's very easy to achieve. But let's turn that into an algorithm. So, for example, if we said we have this list of numbers, and here's the index of each number, index from 0 to 6 for 7 numbers, always 0 based, we might put the smallest number, the first one, in a variable called smallest. So, sorry, let me say that again. We want to put the first number in our list into a variable called smallest. So we're saying initially when we look at the list, we think this is going to be the smallest number. And then what we do is we compare that with each number in the list. And every time we find a smaller one, we update this variable. So for example, when we compare the next element in the list, which has a value of 3, with the value that was in there, which was 5, 3 was smaller, so we update smallest to be 3. We go to the next item in the list. It has a value of 12. Compare 12 with 3. 12 is not smaller than 3, so we don't do anything. Then we go on to the next item in the list, which has a value of 9. 9 is not smaller than 3, so we don't do anything. Next item in the list has a value of 2. and 2 is smaller than 3, so we update smallest to be 2. Next item in the list is 10. It's not smaller, so we don't do anything. And the last item in the list is 33. It's not smaller than 2, so we don't do anything. So now that we've processed the entire list, visited every element in the list, done our comparison, comparing the one that we're looking at with the temporary smallest value. And if it's smaller, we update the temporary value. Once we get to the end of the list, we can be sure that whatever is in that temporary variable is now the smallest. So that's the algorithm that we're going to be using as we work our way through the remainder of this problem. So if we want to find the cheapest product, then the cheapest product is going to be the one with the smallest unit cost. Remember, we had 4 fields: product name, product code, unit cost, and whether it's in the current product line or not. And the only one there that enables us to discover which one is the cheapest is the one that stores the unit cost. So we have a unit cost field, and we can't access that directly because it's locked, okay? It's private. So in order to get access to the unit cost field, we need to use the getter method, and that's the get unit cost, which will return the value that's stored in the unit cost field. To help follow this problem over the coming slides, what I've done is color coded. You can see the indentation that I'm using, and I've also numbered, and I've used color coding with the number. So hopefully this will enable you to follow what's going on over the number of slides that we're about to look at. So the algorithm for finding the cheapest product, similar to what we looked at a moment ago with the list of numbers, looks like this. So we start off by saying, if products have been added to the array list, in other words, if we have an array list that has products in it, that it's not empty, then 1.1, assume that the first product in the array list is the cheapest. So we're going to set a local variable to store this object. Then, for all the product objects in the array list, we're going to visit them and compare the product that we're looking at with the value stored in the local variable. If the current product cost is lower than the cost of the product object stored in the local variable, then we're going to update the local variable to hold the current product object. Otherwise, we don't do anything. Once we get to the end of that list, so we've finished visiting each element in the array list, we're then going to return the name of the cheapest product. Now, the else part corresponds to what we've got up here. So we're saying if products have been added to the array list, then we've done everything that we just described. But if they haven't been added to the array list, then we don't have a list to work on. So we can't do section 1.1, 1.2, and 1.3. We don't have a list to work with. So what we'll do is return a message indicating that no product exists. So therefore you can't find the cheapest product. So this is the algorithm that we're going to work through. And for each of these color coding and numbered items indicated with those lines for the indentation, we're going to write some code. And we're going to look at each specific element in turn now. So the first step 1, was working on the outer if statement. If the products have been added to the array list, then return the cheapest product, otherwise return a message indicating that no product exists. So we've got to figure out, do we have any products in our array list? So what I'd like you to do is think about that, pause for a moment, and see if you can write a piece of code to do that. How do we find out if we have any elements in an array list? That's really what we're asking. So if you can answer that, you've got the first part of this solved. Let's take a look at the answer. We're saying if products, which is the name of our array list, dot size, which returns many elements is in there, if that does not equal 0, then we can do the if statement. Else, we're returning no products are in the array list. So the key to this is looking at our array list, and we have a method that tells us how many elements are in it, and that's the size method. So that's part 1 solved. Let's move on to step 1.1. If products have been added to the array list, then we can assume that the first product in the array list is the cheapest and set a local variable to store this object. So we're looking at the purple section here, and what we're going to do is ask you to consider, how do we write code for this step? So pause the video for a moment and see if you can work out that answer. So here's what the code looks like. In purple, we are saying cheapest product, which is a new variable, and it is of type product. We're declaring cheapest product to be of type product, and we're initializing it to be products, our array list, dot get 0. So 0 is the first index in our array list. We're going to get back that product and store it in cheapest product. And that's the solution to step 1.1. Next, step 1.2, we're working on the for loop. For all product objects in the array list, determine the cheapest product, end for. So what we want to do is take a look at the green section here. How would we visit every element in the array list? Again, how would you implement that code? Pause for a moment, see if you can solve it, and we'll give you the solution in just a second. So here's the solution to visiting every element of the array list. For each product of type product in the products array list with our braces, this is how we would implement step 1.2. We're visiting every element of the array. So well done if you got that right. Just to recap, again, color codes to help you understand. The red product here, this is the type of the object that's stored in the array list. The blue, this is the reference to the current object we're looking at in the array list. As we iterate over the object in the array list, this reference will change to point to the next object and so on. And then the green, this is the array list of product called products. Okay. So we're now visiting every element in the array list, and step 1.2.1, we're testing if the current product cost is lower than the cost of the product object stored in the local variable. So again, in our simple example, we're comparing the two values. How do you do the comparison? So again, how do you write the code for this step? Pause for a moment, see if you can solve it yourself, and then we'll show you the answer in a second. So here's the solution to 1.2.1. We have an if statement. If product at get unit cost is less than our temporary variable cheapest product dot get unit cost. So what's different, or what's worth pointing out here is, remember, we're in a for loop. We're visiting each product in the array list of products, and that variable is called product. So hence the product here, product.getUnitCost. And we're testing if that's less than the cheapest product.getUnitCost. We were storing this object in a temporary variable called cheapest product. We need to get the unit cost method to pull back the value so that we can compare the two values. And again, with each if statement, you've got a parentheses around them, and then you've got your curly brackets. Inside the curly brackets, we're going to implement what we want to do if this is true, which is step 1.2.1.1. We want to update the local variable to hold the current project object. So again, have a think about this. How do we write the code just for this step, this one statement? Update the local variable to hold the current product object. I'll give you the solution in just a moment, so pause here and see if you can come up with that yourself. And here it is. So our solution is we update cheapest product to be the current product. Let's work on the last step, 1.3. So we have, just to go through it, step 1, made sure we had some products in our array list. 1.1, we assumed that the first product in the array list was the cheapest one. We set that in a local variable. 1.2, we visited every element in the array list. And then we compared each element to the current local value. If it was smaller, we updated it. So we've now visited every element in the list. And the last step is to return the name of the cheapest product. So this should be quite easy for you to do. Again, how do you write the code for this final step? Return the name of the cheapest product. Pause here. We'll give you the solution in just a moment. So we're returning. So we've got a return statement. We have this variable cheapest product, and we want to return a string, which is the name of the cheapest product. So we have dot get product name, which will return that string, and that's returned as the value of this method. Okay, so we've just worked our way through finding the cheapest product. And doing that, we looked at a simpler algorithm for finding the smallest number in a list of numbers. And by looking at what we did with that, hopefully that makes it a bit easier to follow the lengthy text and many slides that we've gone through. Okay. Okay, so we've taken a look at product, we've taken a look at store. Let's take a look at driver, the driver class. So our driver class, we need to bear in mind we have to refactor any changes to the store interface. They have to be reflected in this class. And the big change really is the store constructor method. So previously our shop used an array, and we need to know how many products to store when we use an array. But because we're now using an array list, and we can pull back how many products are in the array list with the size method, we don't need to set a capacity. So our our constructor call is simplified. So now we have store is assigned a value, new store, bracket, bracket. So that's the main change that we need to make in order to use an array list. with driver. Now, the next time or next week, we'll be adding a menu system in the driver class. Right now, the user has no control over whether they want to add, list products, find the smallest, etc. But just to give you an idea of where we're going, here we can see typical output for this application. So just take a look at the output there for a second, and we'll work through and explain some of it for you. So in the first question there, we're saying how many products would you like to have in your store? And the green represents user input. So this is version 2. Would have asked how many do you want in your store? You would have had to answer 3, and then you take in 3 products. For each product, you'd have to take in 4 fields, and then those 4 fields would be the values that you took into those for those questions would be used to initialize the 4 fields for each product that you then add to the store. So again, here's our store model. And for each of those products, we would have called add to add the product to the store. For each product, we've got 4 values that we want to store. We also looked at list products today. So we could have called list products and it would list out 0, 1, and 2. But where we're going is you might want to list out the current products, the average price, the cheapest product in the list. Or you might want to view products costing more than a certain price. So we need to have a system that will enable us to call the functionality that we need. And that's going to involve building some kind of menu system. I'm going to see that in next week's class. Okay, so let's take a look at what we've been just working our way through. We're talking about collections. Collections allow an arbitrary number of objects to be stored. By that we mean you don't have to specify up front how many. Collections are implemented in Java's class libraries, which contain tried and tested collection classes. In Java, class libraries are called packages. And we've used the ArrayList class from the Java util package. In relation to the ArrayList collection, we said that items may be added or removed. Each item has an index, and that index may change if items are removed or further ones are added later. Main ArrayList methods, we identified 5. There are more, which you can find in the documentation, but the key 5 ones are add, get, remove, size, and clear. ArrayList is also a parameterized or generic type. And what that means is ArrayList on its own is not good enough. You need to say an ArrayList of, and the of is the parameter. So is it a string or is it some other object? We looked at 2 different types of array lists. We've looked at an array list of strings, and we've also looked at an array list of products today. So we've gone from shop version 2 in our last talk, which had an array of product, and we had a field called total to keep track of how many products were in the array. And we've changed that now in version 3 to use an array list of product. We no longer need to use total because we can find out how many products are in the array list by calling the size method. We looked at the product class in detail. We looked at the store class. Today, we've spent time looking at the fields, the store constructor, and then 3 methods: add, list products, and the cheapest product. So we've gone through the talk. Hopefully you can follow what's going on in the talk, and hopefully you pause the videos when we were asking you to try and work out some of the code yourself. It's really important now that you go through the labs. The labs will take you through making those changes step by step. Okay.